Hello everyone, welcome back. In this video, we are going to continue our conversation about AND behavior. If you check the previous video, you probably noticed what is AND behavior, and you already know what is a rule and what key information can help us to generate the pattern of AND behavior. So today, we are going to use the rule we generated last time, and we are going to use this rule to analyze AND behavior of polynomial. But a little bit different thing today is we are not going to check the graph of polynomial. Instead, we are going to check the expressions of polynomial and see what key information we can use to analyze at the end behavior of polynomial. So let's check several examples now. The first example. As you can see here, instead of using graph, we are going to use just expression of polynomial. So the function of polynomial is given. Now we are going to use this expression only to describe the AND behavior. So in previous video, as we mentioned, in order to find AND behavior, the most important part, we are going to use the two information. The first part is degree. That's the first information we are going to use. And the second part is going to be the leading coefficient we're going to use. So for the degree is a highest exponent, so which is 3, which is odd. And for leading coefficient, which is a number in front of the highest exponent, which is negative. So these two information will help us how the graph look like. If this is odd graph, it will look like this way or this way. So, but when the leading coefficient is negative, so it will look like this kind. So how do we use this one to describe the AND behavior? Remember, we always focus on the negative side, which is left, or the positive side, which is right. So we always, describe the two sides of AND behavior. So we just describe as it is. So as x approaching to the negative infinity, which is on the left side, again, which is going to be the left side. The y, as you can see, for this model is going up, so y is approaching to the positive infinity. As x approaching to the positive infinity, again, this time we're talking about the positive side, which is the right side. And the y, as you can see, this model here is going down, so that's why y is approaching to the negative infinity. This is how we use degree and the leading coefficient to help us to figure out the AND behavior, and this is how we set up the final answer. Okay, so this is what happened for the first example. Let's check another one. This one, we also have expression here with 4 terms already listed in the standard form. So that part, we can just use the first term to tell us the leading coefficient and degree. So the degree, as you can see, the highest exponent is 4, which is even. And the leading coefficient, the number 2 in front of this, which is positive. So as we know, when the degree is even, it will look like this one or this way. But since the leading coefficient is positive, so that's why it will go up at the same time. So that's why this is going to be the graph look like that. So again, we are going to describe the left side, which is negative, and also the positive side, which is on the right side, with 2 parts. So as x approaching to the negative infinity, again, this is the left side, then y is going up, so y is approaching to the positive infinity. As x is approaching to the positive infinity, which is the right side for this one, so let me write down the right, so it's easy for you guys to figure out, and this is the left. And then y is approaching to the positive infinity too, because as you can see the graph, they go up for both sides. So this is how we analyze the AND behavior. This is how we answer look like. But this is, again, this is how we use degree and leading coefficient to figure out the AND behavior. Okay, that's all the example I want to share with you today. Thank you so much for checking this video with me and studying this topic. I hope everyone is doing well, and see you soon, everyone.